Hello everyone, welcome to my channel Enthusiasm. Today we're going to look at an interesting question of factors. The problem is really easy to understand. However, the solving strategy requires a little bit more thought. Let's check it out. From 1 to 1000, which integer has the most factors? First of all, it is not practical to list out all the factors of each integer one by one. Actually, there's a general formula to figure out the number of factors of an integer. Consider a positive integer n. If we can write it as a product of prime numbers, that is, n is equal to p1 to the power of n1 times p2 to the power of n2 all the way up to pm to the power of nm. Here, the indices n1, n2 up to nm are positive integers. Then the number of factors of n is equal to n1 plus 1 times n2 plus 1 all the way up to nm plus 1. In other words, we add up the indices by 1 and then multiply them together. If you are interested in the proof of the formula, let me know in the comment section. I shall make a video on that. So, how do we use this powerful formula to solve the problem? Consider an integer n, where n is between 1 and 1000. Indeed, n cannot have too many prime factors. Why? We will prove it by contradiction. If n has 5 prime factors or more, then we can take the smallest 5 prime numbers, which are 2, 3, 5, 7, and 11. Then n is larger than or equal to the product of these 5 numbers, which is equal to 2310, and this is larger than 1000. So n has at most 4 prime factors. We are going to discuss them one by one. Case 1, if n has 1 prime factor, in order to have a higher number of factors, that prime factor should be as small as possible, so that the index can be as large as possible. In other words, we take the prime number 2. Because 2 to the power 9 is equal to 512, which is more than 1000, and 2 to the power 10 is equal to 1024, which is larger than 1000, so we take 2 to the power 9. It has 9 plus 1 equals to 10 factors. This is our temporary maximum, which may be changed after discussing more cases. Case 2. If n has 2 prime factors, again we choose the smaller prime numbers. So we look at the form 2 to the power p times 3 to the power q, where p, q are positive integers. Let's start with q equals to 1. Just now, we have 2 to the power 9. Let's try p equals to 9. Because 2 to the power 9 times 3 is equal to 1536, and this is larger than 1000, so p should be smaller than 9. We see that 2 to the power 8 times 3 is equal to 768. Using the formula, we find the number of factors, which is x plus 1 times 1 plus 1, and this is equal to 18. So we have to update our maximum. Let's increase q to 2. With a larger q, we take a smaller p. Now, 2 to the power 7 times 3 squared is equal to 1152, and this is larger than 1000. But 2 to the power 6 times 3 squared is equal to 576. It is okay. It has 6 plus 1 times 2 plus 1 equals to 21 factors. Wow, an even higher maximum. Let's update the record. How about q equals to 3? 2 to the power 5 times 3 cubed is equal to 864. It has 24 factors. Another maximum. So you can feel that whenever we change the indices, the highest number of factors may keep on changing. Okay, what about q equals to 4? Starting from this point, I'm going to show you the largest possible integer not exceeding 1000. 2 cubed times 3 to the power 4 is equal to 648, but it has 20 factors only. It does not give a higher maximum, so we can stop at this point for case 2. Case 3. If n has 3 prime factors, we consider 2 to the power p times 3 to the power q times 5 to the power r. Again, let's start with small values. Q and R are both equal to 1. Then 2 to the power 6 times 3 times 5 is equal to 960. It has 6 plus 1 times 1 plus 1 times 1 plus 1 equals to 28 factors. A new record. For Q equals to 2 and R equals to 1, 2 to the power 4 times 3 squared times 5 is equal to 720. The number of factors is equal to 30. Awesome! Next, Q equals to 3 and R equals to 1. 2 squared times 3 cubed times 5 is equal to 540. It has 24 factors only, so it cannot break the record. Alright, now we change R to 2. 2 squared times 3 squared times 5 squared is equal to 900. It has 27 factors only. Up to this point, we cannot further decrease the value of P and increase the values of Q and R. Otherwise, n is larger than 1000. That's all about case 3. Last but not least, we come to case 4. It will surprise you. If n has 4 prime factors, we look at 2 to the power p times 3 to the power q times 5 to the power r times 7 to the power s. Again, we set q, r, and s all equal to 1. Now, 2 cubed times 3 times 5 times 7 is equal to 840. It has 3 plus 1 times 1 plus 1 times 1 plus 1 times 1 plus 1 equals to 32 factors. Another record. Can this be broken? Okay, just increase q to 2. 2 times 3 squared times 5 times 7 is equal to 630. But it has 24 factors only. But the same reason, we can't further decrease the index. So we get the answer. Within 1 to 1000, the integer having the highest number of factors is 840. It has 32 factors, which are shown on the screen. You see, we just used basic tools to solve the problem. If you want to know more interesting questions of number theory, please check out the links of the videos and the playlist on the screen and the descriptions below. See you in next video.